Swayam Prabha. Digital India. Educated India.
So, in my previous lecture, I have discussed about the pseudostatic analysis on retaining wall to determine the seismic force. Okay, and I have already discussed that the consideration of that kh value or the kV value, there is no such proper rule or guidelines. I mean, engineers, they have to use their own judgment when they will choose that kh and kV value, but I have given a few guidelines, and then I said that the taking up kh value is half of the mx by g is okay, but still the engineers, they have to use their own judgment to choose the proper kh value for the pseudostatic analysis for the particular site. Now, in my previous analysis, I have not taken the effect of water table, okay, within the backfill and in the free condition. So, today I will first discuss about the effect of water table on the seismic earth pressure, and then I will go to the pseudodynamic analysis if time permits. So, first if I discuss about the hydrodynamic effect of pore water. Okay. So, I will discuss the hydrodynamic effects of pore water. Okay. Now, suppose if we have a retaining wall, say, okay, and water table is here, and this is our backfill side. There also water table is present. So, both the side in same height, water table is present. So, this is the position of water table in the backfill side, and this is, you can say, the seaward side, this is the landward side, we can say. So, this is and this is the seaward side. Okay, so that means this is backfill. So, this is my backfill. Now, both sides the same height water is present, say. So, that height of the water is small h, and height of the retaining wall, say, h. Now, for the seaward side, when the water table is not in the backfill, first we will discuss about the hydrodynamic force that will act during an earthquake if water is present. Suppose there is a seawater side, so water is present, how much force will act due to this presence of water on the retaining wall. So, that will first calculate. So, that force is called the hydrodynamic force. So, that the hydrodynamic force that will first discuss on the seaward side, and for this side the variation of this dynamic water force in seaward side is this one. Okay, this is the variation. This is the not dynamic force, this is your water pressure, okay, during the earthquake. So, say this is a H, this side also same H, but not necessarily, it can be different H value in the seaward side and the your backfill side or the landward side. Now, if this is the say P1 is the pressure at any depth. So, and we are taking a small segment on this distribution, okay, and that thickness of that segment is dy. So, which is at a height of y from the water level. Okay. So, that means this is the water pressure distribution that I have drawn, and P1 is the any pressure distribution value at any depth, say y, and I have taken a small segment on this pressure distribution, and that segment thickness is dy, which is at a depth of y from the ground, from the water level. Okay. So, that P1, that variation is given by 7 by 8 kh gamma w h to the power half and y to the power half. So, that variation at any depth, if I put any h value, if your h is equal to 0, then Py equal to 0, and this is if h is equal to, if your y is equal to 0, P1 will be 0. If your y is equal to h, then you will get the P1 value at the base. Okay. So, that means this y is at any depth from the water table, and the h is the height of the water from the base of the retaining wall, and kh you know, that is the your pseudostatic coefficient of horizontal acceleration, or sometimes we call the acceleration coefficient or coefficient. Okay. So, that means 7 by 8 this value. So, this was proposed by Westergaard in 1933. So, this was proposed by Westergaard 1933. So, now if this is the distribution at any depth, now I can calculate that P dynamic W or PW dynamic. So, anything I can write. So, here I am writing it is P W, P D W. W means the water, D is the dynamic force. So, that means the dynamic force due to the water on the retaining wall. Clear? P means the force, D is the dynamic, W is the water. So, that means we can write that the total dynamic water force, and that is also per unit length. So, total dynamic water force per unit length, small p1 is this is water pressure distribution. Clear? And from there, using that pressure distribution, I want to determine the total dynamic water force that is acting on the retaining wall per unit length. So, that we can determine easily by integrate that pressure distribution from 0 to h. Okay. So, that is P1 into dy, because at this small segment, what would be the amount of force per unit length, because at this small segment your distribution is P1 and if I multiply with that thickness of that segment dy, then I will get the force on that segment or force due to that segment per length. Okay. So, if this small p1 into dy is the water force or water dynamic water force due to that segment. Now, if we integrate that from over the entire depth of the water, then from 0 to h, then I will get the total force or total dynamic water force that is acting on the wall. Okay. So, that I am doing here. So, that if I now put the value, so this will be 0 to h into 7, P1 is 7 by 8 kh gamma w h to the power half y to the power half. And if I integrate that and put this limit, then I will get finally the value 7 by 12 kh gamma w h square. So, this is the total dynamic force due to water acting on the wall in the seaward side, okay, not in the backfill side. If the water is a free side, not within the backfill. Clear? Now, I have to determine what is the location of this force. So, I say suppose that this force will act here, say. Okay. So, this force will act here, P d water. But what is the height? What would be the height? This y bar. What would be the y bar of that P d, the total force that is acting? So, that now I want to determine. So, that means the location of the resultant water pressure or the total water pressure. Dynamic water force I can say. Okay. So, that I can calculate very easily. Y by how I can calculate? That it is that force into the lever arm divided by the total force. Now, what is the force? Force will be simple that for that small segment. So, this force will be your simple P1 into dy, that is the force, and the lever arm will be y from the top. So, that means this y bar we are calculating from the water or top of the water level. From the top, that is the water level. Okay. So, this is, then I can write, so this is the force P1 dy, P is the force, and the lever arm from the top point, from this point lever arm is y. So, that is the for that small segment. Now, for the entire zone it will be 0 to h, then that will be divided by the total force P d w. Clear? How I will get the this y bar? But remember that y bar is not from the base of the wall, it is from the top of the water surface or water level. So, now if I integrate further, it will be 1 by P d w, then this is 0 to h, P1 is again 7 by 8 kh gamma w h to the power half y to the power half into dy, okay, into y, because there is a y, into y also. because this y is there now. So, now the final thing will be, if I take this 7 by 8, 1 by P d w, and take 7 by 8 out, and k h gamma w h to the power half, we are taking outside 0 to h, then this will be y to the power half into y dy. Okay, into y dy. Now, if I do the integration, then it will be y bar will be equal to 1 by p1 p dw, then this will be 7 by 8 kh gamma w h to the power half. Then if I integrate that, this will be 2 by 5 into h to the power 5 by 2. If I integrate and put the limit, I will get 2 by 5 into h by 2, and then this will be equal to 1 by p dw 7 by 20. 7, this is 420, 7 by 20 into kh gamma w h to the power half plus 5 by 2. So, if I add them, this will be 6 by 2, so it will be 3, h to the power 3. Now, if I put the PD value, now what is the PD value? PDW value, this is 7 by 12 kh gamma w h square. So, this will be 7 by 20 kh gamma w h cube. So, this will be 7 by 12 kh gamma w h square. Okay. Okay. So, now if from there I will get, it is simple, 12 by 20 h, because this will be 7 will cancel. So, it will be 12 by 20 h, or it will be simple 0.6 h. But remember that the h is the height of the water, not the retaining wall. So, that means this is from the top of the water table, it is 0.6 h. Now, from the, if I want to calculate, it is bottom of the retaining wall. So, from the bottom of the retaining wall, it will be simple 0.4 h bottom. Okay. So, I can write y bar is equal to 0.4 h from the bottom of the wall. Okay. Now, there is a question that which direction this force will act on the wall. So, which direction is this force will act? Because your water is this direction and soil is in this direction or this side. Soil is in the right side and water is the left side. Now, when the earthquake will come, so it can, the force can act from left to right or right to left. Now, if it is definitely, if the force that will act due to this soil, that will give the force in the active condition on the wall, and we are all discussing about the active condition. So, it will give the wall. So, the water, the force due to the soil, that will act on the wall from right to left. But your seaward side, the water force, that may act from right to left or left to right. Okay. So, to be in the safe side and provide the worst condition, it is recommended that I will provide the direction of this force in the wall or on the wall in this direction. So, this will be your PDW direction on the wall, remember that. Okay. Or I should put it in the same level. So, if I put it in the same level, so that means this will be the direction of the PDW. Why this is the direction? Why not the opposite? But if you put the opposite, and so this will not give you the worst condition, because basically if you give the direction of this PDW in the opposite that I have shown, then it will increase the factor of safety of your wall. Now, it will not decrease the factor of safety. So, to be in the safe side or to consider the worst condition, this will be your direction of the PWD. That means the total dynamic water pressure or water force. And in the same direction, the force due to soil that will come from the backfill side. So, that is why it will provide a worse condition. Now, the C side, this is clear how to calculate the dynamic water force. So, that I have discussed, and how to locate the application or point of application of that force. Now, what about the backfill side? How this force will act, whether we will consider it or not, because the seaward side, it is in the free condition. Water can easily flow and can hit into the or on the wall. We are putting the your pressure in the direction that will give you the worst condition. But in the backfill side, your water is within the pores of the soil. In what will happen? So, for this backfill side, so before I give the what will happen, so I should give you two conditions. So, if that is the thing, the water in backfill. So, water in backfill, what will happen? We will consider this force or not. So, there are two conditions, that is that restraint pore water condition. Okay. Now, what is the restraint pore water condition? In the restraint pore water condition, it is mentioned that if the permeability of the soil, is small enough, that typically it is less than equal to 10 to the power minus 3 centimeter per second. Okay. So, if the permeability of the soil is small enough, typically less than 10 to the power minus 3 centimeter per second, the pore water that will move with the soil skeleton during the earthquake. That means, no relative movement between the pore water and the soil. So, that condition is called restraint pore water pressure condition, pore water condition. That means, if your pore water pressure is very small, if your permeability of the soil is very small or small enough that the movement of the water during the earthquake and the soil skeleton are same. That means, the soil water will move along the soil particle. Okay. So, that condition is called restraint pore water pressure pore water condition. Okay. So, that means, there will be no relative movement between soil and the water. So, the pore water will move with the soil. So, that means, here I can write that pore water moves with the soil. No tip movement between the soil and water. Clear? That means the permeability is very less. So, that means it will move with the soil only. Water will move with the soil, no relative movement between the soil and the water. So, that is one condition. Another condition is the free pore water condition. If the permeability of the backfill soil is very high, previously it was very small or small enough. Now, if the permeability of the backfill soil is very high, that the pore water may remain stationary. It looks like that when the earthquake force will act, as the permeability is very high, it looks like the pore waters are remain stationary and soil particles or the soil skeleton is moving within the water. Clear? Because your waters are very permeability very fast. So, that means your water movement is so fast, but it looks like that it's stationary as compared to the movement of the soil particle. So, it looks like that your water is stationary and soil skeleton or particles are moving within the water. So, it is moving left to right or upward or downward. Clear? So, in this free water pore water condition, soil water looks like a stationary condition and soil particles are moving or the soils are moving within the water. Clear? So, that means the soil skeleton they moves back and front. So, that means here I can write that the pore water may remain stationary. And soil skeleton moves back and forth. Definitely there will be the relative movement between the soil particle and the pore water. So, it is recommended that at free pore water pressure condition, we have to consider that hydrodynamic force. Okay? So, hydrodynamic force water pressure or force can also be developed under free water condition. So, remember that if it is free water condition, as I mentioned, when the permeability of the soil is very high, then the hydrodynamic water pressure or force can also be developed, and we have to consider this hydrodynamic force in the backfill side along with other forces. Clear? So, but that means in free pore water pressure condition, both in seaward side and the landward side, your hydrodynamic force will act. Clear? So, this is for this free pore water pressure condition. Clear? But if it is resistant pore water pressure condition, then we will not consider that this dynamic water pressure or force in the backfill side. Clear? So, free pore water pressure condition we will consider if it is if it is free pore water condition, then we will consider the PWD in or PDW, that means the dynamic water force both in landward side or the backfill side and the seaward side. But if it is resistant pore water condition, then we will consider only it is in seaward side, not in the landward side. Okay. So, that is one thing. Now, there is few question that still, if it is, because we have discussed if it is very this water pressure is very large or high enough or it is small enough. That means the two extreme condition. Now, what will happen in between that if the water pressure is between that? So, again that I should say there are few recommendations are available, few researchers are saying that don't consider the your this hydrodynamic force in this situation. It is only if it is free pore water condition, but some has mentioned that you take 70% of that PWD in the backfill side. So, again that engineers have to use their judgment, but here I would recommend that if it is free pore water condition, then you consider it, and if it is resistant pore water condition, then don't consider it. So, if you see that the permeability is high enough, then you consider it. If you feel that permeability is not high enough, then don't consider it. If you feel the permeability of the soil is small, then don't consider it. If you feel the permeability of the soil is high enough to produce the free pore water condition, then only you consider it. Okay. So, now in my next lecture, what I will discuss, that I will show all the forces that will act on a retaining wall, or specifically this retaining wall where the water is present in seaward side and the backfill side, or sometimes it is called the waterfront retaining wall. So, I will discuss all the forces and I will give you the equation of all the forces, and probably in next lecture I will solve one numerical problem also and show you how we can calculate the or we will check the stability of such retaining wall under considering all the forces. Here we have discussed only one force, that is the hydrodynamic force, and I have discussed when you seaward side always you have to consider, but in the backfill side when you consider it, when you will not consider it, that also I have discussed. Thank you.